So we're continuing on exactly where we left off. So if you didn't watch 2.5, the first video, you might want to go back. I'm going to label this 2.5b. And yeah, as we look at number 13, this time they give you the point. And you might be saying, okay, well, why are they giving me the point here? Is because if we're wanting the equation of the tangent line, we need the x and the y coordinates. Well, they don't give us any y coordinates up here. They only give us the slopes of each of these. So when we're looking at h of 3, we need to then figure out what h prime of 3 is for the slope. So this is your slope. So where are we at? H prime of 3 is -3. Whoops, I went way too far down. So the tangent line, all right, TL for tangent line, is I like to write as y equals the slope, and then x minus your x coordinates, and then plus your y coordinates. So then the normal line, because it also asks for that, I'm going to write NL for normal line. It's still y equals, but now you want the perpendicular slope. So the perpendicular to -3 would be positive 1/3 because it's the opposite reciprocal. And everything else is the same, and don't waste your time simplifying that because that's all you need. So why do we do that? Is because then we could look at this and approximate the tangent line for h of 3.1. So we know when h is 3, it's 2. Well, now we can figure out, well, what about the tangent line approximation? I should put about symbol. Plugging in 3.1 in for x, -3 plus 2. Well, that's pretty straightforward because now it's -3 times 0.1 plus 2, which is -0.3 plus 2, which is telling me then that's about 1.7. Now, as far as is this approximation greater than or less than the actual value, that's kind of a tricky question right now. But all we know in the problem is that we have a polynomial, this piece right here, which I'm not sure if we've even covered concavity yet, but this is a good introduction into concavity. If something is concave up, that means it's an upwards U. Okay, so what that means, I should change colors probably, is at that value we have an upwards U. Now we don't know which side of x equals 3 we're on. You know, maybe it's an upwards U that looks like this at x equals 3, or it could be an upwards U on the other side like this. Well, no matter how you draw that tangent line, so if it's a tangent line like this, or if it's a tangent line like this, actually we do know because we know it's a decreasing function, and right here I just drew an increasing function. So I should probably cross this one off. Either way you draw it though, you notice where my tangent line is located. My tangent line is under the curve because of the concavity. So when it's under the curve, my approximation is less than. So your answer is this is an under approximation. That's usually how we say it. We don't normally say it's less than. This is an under approximation. And the only reason that you need to say, since h is concave up, CC up at x equals 3. And we'll get more into concavity in a little bit. We throw in some limit problems as well. And again, you have to go back to the directions up here. The directions say that these are the only zeros. They're polynomials. So the fact that we have an increasing function to the left, and I'll write that down. This is an increasing function to the left, and then it's decreasing to the right. In other words, our graph looks something like this. that's kind of your clue to what's your end behavior for the limit as x approaches negative infinity. It's going infinitely down. Same thing with this. This is going infinitely down as we move more and more to the right. Yeah, so investigate that, pause the video, see if you really understand. Feel free to ask me in class or reach out to me through email. Here's another set of problems that there's a lot going on. There's a lot to unpack. But what I would point out is technically with this derivative, we do have a negative leading coefficient. And so I'm looking at this. We have a negative leading coefficient. Now be careful, because if you have two of these, a negative times a negative will make this a positive. So what I'm going to do is, in order to find where the function is increasing, decreasing, I'm going to make a sign chart. Now what I'm going to add to my sign chart is a place for the leading coefficient at the top. This is how I like to do this. So I'm going to look at my zeros. So we have a 0 at 0, 2, and negative 3. So negative 3, 0, and 2. I wish I gave myself just a little bit more space. And so at negative 3, at 0, and at 2, so negative 3, 0, 2, you probably remember from the previous videos and pre-calculus that to the left of zeros are negatives, to the right are positives. Now here's the thing with the leading coefficient. And if you're still confused with the leading coefficient, multiply this out and you'll notice it'll end up being a negative x cubed. So that's why I make a sign chart that has one more row for the leading coefficient. So if I have a negative times a negative times a negative times a negative, I have a positive here. 3 negatives is negative. 2 negatives is a positive, and then 1 negative is negative. So I make the sign chart to show that, okay, well, if f prime of x is greater than 0, that implies that f of x is increasing on the interval from negative infinity to negative 3, and then also from 0 to 2. Now again, if you're asked to write the open interval, you would put it with parentheses. And then you can flip that for where it's decreasing. And this sign chart is a justification. It means f of x is decreasing on the interval from negative 3 to 0, and then from 2 to infinity. And I can talk about this just one more way, is from Algebra 2. If you FOILed all this out, you would have a negative leading coefficient with an odd degree, and that would be your clue that, oh, well, a negative leading coefficient with an odd degree looks something like this. So it was decreasing first, and then increasing, and then decreasing. I'm sorry, I just said that wrong. This is what the graph looks like, of the derivative. So it looks something like that. So even though, yes, this graph is decreasing first, the derivative is positive here. That's what I meant to say. And it's positive in between, and then here and here are negatives. So that does confirm my answer. Okay, so that can help us actually find at what x values. We don't know the y values. Do we have a relative min? Well, in order to have a relative min, the curve has to be like this, which means that the slope must change. So f prime of x changes from negative to positive, because that's what makes the function go from decreasing to increasing. So where do we change from negative to positive? At x equals 0. All right. So relative max would be the opposite. We want to go from increasing to decreasing. Well, that means that the derivative changes from positive to negative. Well, where does that happen? X equals -3 and x equals 2. If it helps, I don't know if it helps, just draw arrows. If the derivative is positive, that means it's increasing. If the derivative negative, it's decreasing. Connect those dots. That's a maximum. I hope that helps. So it's got to be a minimum at x equals 0. And then it has to be decreasing. So x equals 2 is a maximum. Then they give you this other piece where they say they give you f of 4 equals -1. Well, if we're trying to find the equation of the tangent line, we need to know what f prime of 4 is. Well, we can identify that by using the formula that they give you. So 4 times -2 times 7. So -8 times 7 is -56. So now just write the equation. Y equals your slope, x minus the x coordinate, and then minus your y coordinate. There you go. You can see I've done these problems a lot, which you should as well. So now we can go look at the next thing. We can approximate when x is 4.1. And notice that we always have a small difference. We don't want to approximate too far away from that tangent line, because then you might as well use a different value. Well, 0.1 times -5.6 would give me -5.6. Minus 1 would give me -6.6. And back to the clue, it tells you it's concave down. That means it's a downwards U. Okay, it might look like that, or it might look like this. Now the fact that it's a negative slope, that's a good indicator that it looks like this. Because if I had a tangent line over here, then it would be an increasing function. So this is probably more accurate. But either way you draw it, the concave down, the downwards U, is showing you a tangent line that's above. So this would be an over approximation. Because it's concave down at x equals 4. That's your reasoning. All you have to do is say the function's concave down. The tangent line's above then. I think I just have a few more problems, and yeah, I think I can get this done. So they tell you that p prime of x is the graph. So if the function is decreasing, we're looking for where p prime of x is negative. So below the x-axis. So I would just say, because it doesn't say open interval, I would just say all values between -3 and 3. Now I'm going to show you the answer key real quick, because they sometimes, when they want an open interval, they want you to exclude at x equals 0. I just don't like that, because if it's decreasing to the left and it's decreasing to the right, you can just say it's decreasing throughout. That's why I've changed my way and I go ahead and use brackets. I already forgot where I had it. Okay. What about where it's increasing? Well, that needs to be where p prime of x is positive, so above the x-axis. That's between -∞ to -3. And then from 3 to infinity. So what about a relative max? That means p prime must change. So it changes from an increasing function to a decreasing. So that means the derivative must go from positive to negative. Well, where does that happen at? At x equals -3. Really the same reasoning for the next one, except now we're at x equals +3, and I'm going to defer to the answer key again. Feel free to pause the video to write this down. Notice that sometimes math teachers write it a little bit differently, but you know, changes from negative to positive, you know, things like that. And again, I'm running out of time, so I'm just going to scroll down to get to the last answer, because I really don't want to make this video for, you know, this one last problem. And you can answer this question, and you're ready for the homework. So pause the video, soak it in, and you're good.